Hi, welcome to Varenya's Photon Online Educational Academy for IIT and NEET examinations. This is Guntuka Srinivas. This is a free online educational channel meant for 8th standard class to the 12th standard class. In this channel, we discuss the basic concepts that are required for the IIT and NEET examinations, especially in the physics, chemistry, and mathematics. Go through all the videos, and this channel is especially to cater the needs of the students in this pandemic situation. Here, in this channel, initially we go slowly, we concentrate only on the basic concepts and simple problems. Then later, we take up the advanced levels. Hence, I request you to concentrate more on the concepts and practice the questions very well. Let us go to this session. And previously, we have seen about the distance and displacement concepts. Let us take up some more problems in this session. The first problem I take up is a man walks from the corner A of a room in the form of cube of size small a to the other corner B, as shown in the figure. Find the displacement. That was the question given. Yeah, but it says that man is walking from the corner A of the room. Room is in the form of a cube of side A, and to the other corner B, as shown in the figure is provided to you. Now he is asking, his interest is to calculate the displacement. Clear? Let us see this question. Observe. This is a cube. This is a cube. Clear? This is a cube. The sides are given A, all are equal. The cube sides all are equal sides. Clear? The point he has given is, this is the point, one corner of the cube A, the other corner is B. other corner is B. That was given. Now, he says that what is the displacement? He is asking displacement. His interest is displacement. Displace. Yeah, that was his interest. Now observe, if I join this initial point is A, here, and slowly the man is walking here, this direction. Then he is walking in this direction, upward direction. Then he is walking in the backward direction. Observe, here I am showing the directions. Man is starting, initial point is here, walking like this, here to here. Then upward direction, here to here. Then the backward up to the final point P. Up to the final. Okay. Now he's asking, this is the path length. Path length is original length traveled by the man. A here, again upward, again this. Path length is nothing but distance. But he is not asking distance. He is asking the displacement. Hence, what is the displacement? In the previous class we have seen the length of the straight line joining the initial point to the final point. That is here, if I join these two, that is initial point to the final point. AB bar, AB bar, AB bar is displacement. Yeah, AB bar is displacement. Okay. Now, observe, general coordinate system we are following is three-dimensional. Three-dimensional. Observe, if A is the initial point, I am taking the coordinates of A as 0, 0, 0, three-dimensional, X coordinate, Y coordinate, Z coordinate. 0, 0, 0, 0, 0, X coordinate, Y coordinate, Z. Yeah, that means this is origin. A is initial point is origin. Clear? Now this is x-axis, positive x-axis. Okay, here I am showing. This is extending in the dotted lines. Extending in the dotted lines. Positive x-axis. This is up, up, extending in the dotted lines. Again, up. This is positive y-axis. Positive y-axis. Clear? Now, this is this side. This side I am showing outward. This is outward. This side I am showing positive z-axis. Yeah. So positive x-axis towards east side. Upward is positive y-axis. This side is positive z-axis. That is our sign. Yeah. Now, assuming that A is initial point is origin, X coordinate is 0, Y coordinate 0, Z coordinate 0. Yeah. Now, I want to find out the coordinates of B. So, the coordinates of the B I require. So, here origin. How to find out the coordinates of B? Man is walking towards B, towards X direction, how much? A, towards X direction, A length. Is walking A to X direction, A, small a. And towards Y, upward Y, upward. Be careful. Towards X direction, positive X axis, plus A. And towards Y direction, upward. Again, this is also A, because cube having the all sides are same, small a. So this is A. So again, positive A. But man is working, observe, this is Z. Outward Z is positive. but man is walking year to year, year to year, year to year, A, but inward. Arrow mark shows inward. This is outward. Arrow mark is showing inward. So minus A. So the coordinate of Z is minus. Means here I put up all the coordinates. So A coordinate is 0, 0, 0. B coordinate is A, minus A. Here. Now, I want to denote the displacement vector AB bar. Displacement vector AB bar. So AB bar is a vector. Clear? The distance between A and B, initial line, final point, straight line, shortest distance. So now that is equal to the difference of these coordinates, the difference of the in the form of vector A minus 0, A I bar, I cap, A minus 0, Y plus A J cap, minus A minus 0, minus A K cap, K cap. This is the vector notation. Clear? Okay. That means AB bar is the displacement vector, AI cap, AJ cap minus AK cap. These are all shown in the vectorial form. Vectorial form. Clear? Towards positive x-axis, A magnitude, I cap. Towards positive y-axis, A, this is positive and unit vector along that J cap. Towards negative z-axis, A magnitude minus K cap because negative. Towards it is going. That is the vector form. In the previous sessions, we have seen how to find out a vector form, how to represent in the form of a vector. Is it clear? Okay. That is the vector. Now, observe. Here I am showing. Suppose A is a point. A is a point. X1, comma, Y1, comma, Z1. B is a point. X2, comma, Y2, comma, Z2. If I want to represent AB bar vector starting from A to B, tail to head AB bar vector. Clear? That is here I am showing A, B bar vector if I want to show. Then simply the difference of the coordinate x2 minus x1 I cap plus y2 minus y1, y2 minus y1 j cap plus z2 minus z1, z2 minus z1 k cap. So x direction, y direction, z direction. This is the general notation to find out the vector AB. Same we have done in the previous case. Clear? In place of A, 0, 0, 0. In place of B, A minus A, A minus C. Clear? So AB bar vector found was the above case. A I cap, A J cap plus there is the minus A K cap. Now magnitude of this I will need. Magnitude of displacement is modulus of AB bar. So square root of coefficient square A square, coefficient square A square, plus again coefficient square, minus stands only for direction A square. So this becomes 3 A square under root. So AB bar magnitude modulus is root 3 into A. Clear? This is the displacement. So magnitude of the displacement. Magnitude of displacement. Okay. Now, how we have found? He is starting from A, again going up, again going back. One corner of the room to the other corner of the room, A to B, initial to final point. Clear? Now, let us see the second question. Take the second question. That is, here, a man walks towards south, towards south, 2 meters, turns right angles, and walks 3 meters towards east, then takes a turn, 60 degrees with respect to east, moves 5 meters. What is the displacement? Yeah. So what is asking? South is moving 2 meters. Then taking a right angle, walking 3 meters towards east. Then again taking that 60 degrees turn with respect to east. Be careful, with respect to east, moves 5 meters. What is the displacement? Yeah. Now let us see this one. Observe, this is a general sign convention. East, positive. This is west. This is the north. This is south. These are the sign convention. Upward north, downward south, rightward east, leftward west. Yeah. What he says, let us say that man is here at A position. Okay. He is walking towards south. South is down. Towards south. That means up to the 2 meters he is walking. Up to B. Then he is taking right angles, walking how much? 3 meters towards east. 3 meters towards east. Up to C. Okay. Again, now observe dotted line showing the east direction. With respect to east, he is turning 60 degrees. With respect to east, he is turning 60 degrees up to D. This is 60 degrees with respect to east. Okay. How much is walking? He is walking 5 meters. What is the displacement? Is asked. Clear? Now, what is the displacement? Before that, let me show the directions. Man is walking A to B, south, down, 2 meters. Clear? Direction. Then B to right angles, towards east, rightwards, 3 meters, direction. And again from C to D, taking 60 degrees with respect to east. This is east. So direction is this. Yeah. Now what is the display? This is AB, BC, CD. This is distance. If you sum up AB, BC, CD, that give the distance. But it does not require distance. It requires displacement. What is displacement? The initial point A, final point D. If you join the line, the shortest distance between the 2 points is nothing but the displacement. Yeah. Now, I am interested in the AD. AD is the displacement. Clear? From the simple mathematics, from simple mathematics, if I draw a parallel line, parallel to ground, that is BC, parallel to ground, BC, BC. Okay? And if I draw a perpendicular from D to down here, this is perpendicular. Let us say here I am giving them E letter, DE perpendicular to the ground. And this is, let us say, the intersection of parallel line to BC, this, and DE. BC line parallel to BC, and from D to a line perpendicular to BC extended line, DE, this point, let us say F I am giving. Okay. ADF is a right angle triangle. ADF is a right angle triangle. Clear? So observe. Angle A right angle AFB is a right angle triangle. Right angle triangle. Clear? Now I require AD. In the right angle triangle, if I apply the Pythagoras theorem, this is the Pythagoras theorem. So what is the Pythagoras theorem? It says that base square plus height square is hypotenuse square. So AD square is equal to base square AF square plus height FD square. Is it clear? FD square. If I know AF, if I know FD, I can easily find out the AD. Clear? Observe this. I want the FD as well as AF. Now from this figure, what is AF? AF, which is parallel to BE. That means AF is BC plus C. AF is parallel to BE. So AF is equal to BE. BE is equal to BC plus C. That means if I know this C as well as the complete D from this triangle, I can easily calculate the other things. Okay. Observe here, I am rewriting again this one. This is the figure, highlighting A, B, C, D. Again, this is extended. This is the perpendicular drawn. This is the perpendicular lines. Clear? So this is displacement. This is displacement. The displacement AD. Okay. Now, you know, this is 2 meters. BC is 3 meters. This is 5 meters. This is 60 meters. And here, this is a parallel line. This is a parallel line. Okay. This is F. This is E. Okay. Now observe. In right angle triangle, CED. CED. Right angle triangle CED. Clear? What is cos theta? Cos 60 is adjacent side CE by hypotenuse CD. Adjacent side CE by hypotenuse CD. So CE by C. So cross multiply. CE is CD into cos 60. CD is how much? CD is 5. So 5 cos 60 half. So it is 2.5. Yes. C is 2.5. That means year to year it is 2.5 meters. Okay. Similarly, observe the same triangle CED, CED, sin 60. The same triangle CED, that angle triangle sin 60. Sin 60 is opposite side DE by CD. DE by CD. Opposite side by hypotenuse CD. So DE we don't know. DE we don't know. CD we know. How much? 5. Cross multiply. So D is equal to 5 sin 60. Sin 60 is root 3 by 2. 5 into root 3 by 2. So this becomes 2.5 root 3 meters. 2.5 root 3 meters. Clear? That means we got D, we got C. So this is D is 2.5 root 3 meters. DE. Clear? Okay. Now observe AF we require. AF is parallel to BE, but BE is BC plus C. BC is how much? 3 meters plus 2.5. Okay. BC is 3 meters plus 2.5. That means BE is 5.5 meters, which is parallel to AF. We got AF. Similarly, we require DF. DF. Out of DE, which is 2.5 root 3, if I deduct this 2 meters AB, because this is parallel here, AB is parallel to EF, this is 2 meters. So out of DE, 2.5 root 3, if I deduct this 2 meters, I will get this DF. Clear? Now I am going further. This is the A, B, C right angle, B, then this is displacement vector. So this is initial, this is D. Now observe. Now here, this is E point. Then if I join, this is triangle. So F point. Okay. So this is 2 meters. This is 3 meters. This is 2.5 meters. This is again 2 meters because parallel to it. So D is 2.5 root 3 meters. Okay. Now, we require AF. AF is parallel to B, which is equal to BC plus C. BC plus CE. BC is how much? 3 and CE 2.5. 3 plus 2.5. So AF is 5.5 meters. Here, next, we require D. We require D. DF. We require DF. Out of D, if EF is deducted, EF is equal to DE minus EF. So D is how much? 2.5 root 3 minus EF is 2 meters. I simplify this 2.5 root 3, 2.5 root 3 minus 2. I will get the DF. I will get the DF. Clear? That's what it is. Okay. Now, if I simplify 2.3, that becomes 4.330 minus 2 meters, which becomes DF is 2.330 meters. This is 2.330 meters. Okay. Now, observe carefully. I got AF, I got DF or FD. Simply from this AFD triangle, from AFD right angle triangle, okay, AF square, base square plus DF or FD square and the root gives the A. Clear? Now, finally, I'm going for that. So, AD square displacement is AF square plus FD or DF square. AF you got, that is 5.5 meters square plus FD you got 2.330 whole square. So AD, finally AD on simplification gives 5.972 meters. AD is finally on simplification. Okay. This AD bar, this is displacement because it is a vector. So displacement, vector AD bar. And this stands for the magnitude modulus of displacement vector AD bar modulus. This is magnitude. What is direction? Direction from A to initial point to final point. Clear? Simple mathematics, Pythagoras theorem we have. Okay. Hope you understood well. If you like the channel, please share it, subscribe it. Thank you very much. And before that, I would like to stress one point. Practice well, practice. If you regularly practice, definitely you will improve your capacity to solve the problem. Thank you very much.